Let's start with a review of the foundations of responsible AI. What is responsible AI and why it matters? What is a primary goal of responsible AI? Is it A, to maximize AI performance? B, to ensure ethical and fair AI usage? C, to reduce AI development costs? Or D, to increase AI adoption? The answer is B, to ensure ethical and fair AI usage. Responsible AI aims to ensure AI systems are fair, transparent, and accountable, minimizing biases and ensuring ethical use. Why is transparency important in responsible AI? Is it A, to improve AI speed? B, to reduce development time? C, to build trust and accountability? Or D, to increase AI complexity? The answer is C, to build trust and accountability. Transparency allows stakeholders to understand AI decision-making processes, building trust and accountability.
Have you noticed the code in the bottom corner? Next time you're stumped, take that code to birdsy.ai for immediate help and a free study session with Birdsy, your personal AI study partner. Plus, you'll get access to hundreds of additional questions, helping you move closer to passing your exam with confidence. The next time you're feeling unsure or stuck, give it a try.
A company is deploying an AI system for hiring. What aspect of responsible AI should they prioritize to avoid bias in candidate selection? Is it A, fairness? B, efficiency? C, scalability? Or D, cost-effectiveness? The answer is A, fairness. Ensuring fairness is crucial to prevent biases in AI systems, especially in sensitive areas like hiring. Microsoft's 6 responsible AI principles. Which of Microsoft's responsible AI principles focuses on ensuring that AI systems are designed to be inclusive and accessible to all users? Is it A, fairness? B, inclusiveness? C, accountability? Or D, transparency? The answer is B, inclusiveness. The inclusiveness principle ensures AI systems are accessible and usable by people with diverse abilities and backgrounds. A company is deploying an AI system that makes hiring recommendations. Which responsible AI principle should they prioritize to ensure the system does not discriminate against any group? Is it A, fairness? B, reliability and safety? C, privacy and security? Or D, inclusiveness? The answer is A, fairness. Fairness is crucial in preventing discrimination and ensuring that AI systems treat all groups equitably. Which principle is primarily concerned with ensuring that AI systems are understandable and their decisions are explainable? Is it A, reliability and safety? B, accountability? C, inclusiveness? Or D, transparency? The answer is D, transparency. Why this question may seem a bit tricky. Transparency and accountability are often confused, but transparency specifically focuses on making AI systems understandable. Fairness and bias mitigation. Definition of fairness and sources of bias. What is a common source of bias in machine learning models? Is it A, high computational cost? B, biased training data? C, complex algorithms? Or D, overfitting? The answer is B, biased training data. Bias in machine learning models often arises from biased training data, which reflects historical prejudices or imbalances. A company uses a machine learning model to screen job applicants. They notice the model favors candidates from certain universities. What concept does this situation illustrate? Is it A, algorithmic fairness, B, data privacy, C, institutional bias, or D, model accuracy? The answer is C, institutional bias. This scenario illustrates institutional bias, where the model reflects existing societal biases favoring certain educational backgrounds. In the context of fairness, what does the term demographic parity imply? Is it A, equal positive outcomes across groups, B, equal error rates across groups, C, equal treatment of all individuals, or D, equal data representation? The answer is A, equal positive outcomes across groups. Why this question may seem a bit tricky, demographic parity can be confused with other fairness metrics, but it specifically means equal positive outcomes across groups. Techniques and tools in Azure to assess mitigate bias. What is the primary purpose of using the FairLearn toolkit in Azure Machine Learning? Is it A, to improve model accuracy, B, to assess and mitigate bias in models, C, to enhance data privacy, or D, to optimize model performance? The answer is B, to assess and mitigate bias in models. FairLearn is designed to assess and mitigate unfairness in machine learning models, ensuring equitable outcomes across different demographic groups. You are using Azure Machine Learning and notice that your model's predictions are biased against a particular demographic group. Which Azure tool should you use to analyze and address this issue? Is it A, Azure Monitor, B, Azure Security Center, C, FairLearn, or D, Azure Data Factory? The answer is C, FairLearn. FairLearn is the tool in Azure Machine Learning that helps analyze and mitigate bias in models, providing insights into fairness across different groups. Which aspect of the FairLearn toolkit might lead to confusion when assessing model fairness? Is it A, it only works with binary classification models, B, it automatically corrects all biases, C, it requires extensive data pre-processing, or D, it offers multiple fairness metrics? The answer is D, it offers multiple fairness metrics. Why this question may seem a bit tricky, FairLearn provides multiple fairness metrics, which can be confusing if users are not familiar with how each metric applies to their specific context.
If you're finding this helpful, please take a minute to like this video and subscribe to our channel for more practice exams, useful tips, and complimentary study sessions with Birdsy.
Transparency and explainability. What transparency means. Interpretability. Model explanations. What is the primary goal of model interpretability in AI systems? Is it A, to increase the speed of AI computations, B, to make AI systems understandable to humans, C, to enhance data privacy, or D, to reduce the cost of AI deployment? The answer is B, to make AI systems understandable to humans. Model interpretability aims to make AI systems understandable to humans, allowing users to comprehend how decisions are made. A company uses a machine learning model to predict loan approvals. They want to ensure customers understand why their applications are approved or denied. What aspect of transparency should they focus on? Is it A, data accuracy, B, algorithm efficiency, C, model explanations, or D, user interface design? The answer is C, model explanations. Model explanations help users understand the reasoning behind predictions, crucial for customer trust and transparency. Which of the following is not a benefit of model interpretability? Is it A, improved user trust, B, Enhanced regulatory compliance. C. Facilitated debugging and error correction. Or D. Increased model performance. The answer is D. Increased model performance. Why this question may seem a bit tricky. Interpretability is often confused with improving model performance, but it primarily aids understanding, not performance. Azure tools for interpretability and what-if analysis. Which Azure tool is primarily used for interpretability and what-if analysis in machine learning models? Is it A. Azure Machine Learning's Interpretability Package, B. Azure Cognitive Services, C. Azure Data Factory, or D. Azure DevOps? The answer is A. Azure Machine Learning's Interpretability Package. Azure Machine Learning's Interpretability Package provides tools for understanding model predictions and performing what-if analysis. A data scientist wants to understand the impact of changing input features on model predictions. Which Azure tool should they use for this what-if analysis? Is it A. Azure Synapse Analytics, B. Azure Machine Learning's what-if tool, C. Azure Logic Apps, or D. Azure Functions? The answer is B. Azure Machine Learning's what-if tool. Azure Machine Learning's what-if tool allows users to simulate changes in input features and observe the effects on model predictions. In Azure Machine Learning, which feature is essential for understanding the contribution of each feature to a model's prediction? Is it A. Model accuracy, B. Data drift detection, C. Feature importance, or D. Hyperparameter tuning? The answer is C. Feature importance. Why this question may seem a bit tricky. The term feature importance might be confused with other interpretability tools, but it specifically refers to understanding feature contributions. Accountability, governance, and traceability. Accountability in AI development, roles, oversight, audits. What is the primary role of an AI ethics board in AI development? Is it A. To develop AI algorithms, B. To oversee ethical considerations, C. To market AI products, or D. To manage AI project budgets? The answer is B. To oversee ethical considerations. An AI ethics board is primarily responsible for overseeing ethical considerations and ensuring compliance with ethical guidelines in AI development. Which of the following is a key component of accountability in AI development? Is it A. Transparency, B. Profit maximization, C. Data obfuscation, or D. Algorithm complexity? The answer is A. Transparency. Transparency is crucial for accountability as it allows stakeholders to understand and evaluate AI systems. A company is developing an AI system for medical diagnosis. What should they prioritize to ensure accountability in their AI development process? Is it A. Maximizing system speed, B. Reducing development costs, C. Conducting regular audits, or D. Increasing user base? The answer is C. Conducting regular audits. Conducting regular audits ensures that the AI system adheres to ethical and regulatory standards, maintaining accountability. In AI development, who is ultimately responsible for ensuring the system's accountability? Is it A. The AI developer, B. The project manager, C. The ethics board, or D. The organization? The answer is D. The organization. Why this question may seem a bit tricky. Accountability can involve multiple roles, but the organization as a whole is ultimately responsible for ensuring accountability. Model lineage, versioning, logging, and tracking in Azure. What is the primary purpose of model versioning in Azure Machine Learning? Is it A, to increase model accuracy? B, to track changes and ensure reproducibility? C, to reduce computational costs? Or D, to enhance data security? The answer is B, to track changes and ensure reproducibility. Model versioning in Azure Machine Learning helps track changes and improvements over time, ensuring reproducibility and accountability. Which feature in Azure Machine Learning helps in tracking the lineage of a model? Is it A, model deployment? B, data encryption? C, lineage tracking? Or D, cost management? The answer is C, lineage tracking. Azure Machine Learning provides lineage tracking to understand the data and processes that led to a model's creation. You are tasked with ensuring that all model training runs are logged for audit purposes in Azure. Which feature should you use? Is it A, experiment logging? B, model deployment? C, data encryption? Or D, cost management? The answer is A, experiment logging. Azure Machine Learning's logging feature allows you to record all training runs, ensuring accountability and traceability. In Azure Machine Learning, which component is crucial for ensuring model traceability? Is it A, data lake? B, compute instance? C, pipeline? Or D, model registry? The answer is D, model registry. Why this question may seem a bit tricky, the term traceability might suggest multiple components, but the model registry specifically ensures traceability by maintaining a record of all model versions. Privacy, security, and inclusiveness. Privacy and data protection, differential privacy, anonymization. What is the primary goal of differential privacy in data protection? Is it A, to encrypt data during transmission? B, to ensure individual data points remain unidentifiable? C, to anonymize data by removing identifiers? Or D, to compress data for efficient storage? The answer is B, to ensure individual data points remain unidentifiable. Differential privacy aims to provide insights from data while ensuring that individual data points cannot be identified, thus protecting personal information. Which technique involves adding noise to data to protect individual privacy? Is it A, differential privacy? B, data encryption? C, data masking? Or D, data compression? The answer is A, differential privacy. Differential privacy involves adding noise to data to obscure individual contributions, ensuring privacy while allowing data analysis. A company wants to analyze customer data without compromising individual privacy. Which method should they use to ensure data privacy while performing analysis? Is it A, data encryption? B, data anonymization? C, differential privacy? Or D, data masking? The answer is C, differential privacy. Differential privacy allows data analysis while protecting individual privacy by adding noise, making it suitable for this scenario. Why might anonymization alone be insufficient for protecting privacy in large datasets? Is it A, it always ensures complete privacy? B, it is the same as differential privacy? C, it encrypts the data? Or D, patterns can lead to re-identification? The answer is D, patterns can lead to re-identification. Why this question may seem a bit tricky. Anonymization removes identifiers, but in large datasets, patterns can still lead to re-identification, which is often overlooked. Inclusiveness, ensuring diverse representation. Accessibility. What is a key consideration for ensuring inclusiveness in AI systems? Is it A, diverse representation? B, high computational power? C, low latency? Or D, cost efficiency? The answer is A, diverse representation. Ensuring diverse representation in AI systems helps prevent bias and promotes fairness. It is crucial to include diverse datasets and perspectives. Which aspect of AI development focuses on making technology accessible to people with disabilities? Is it A, scalability, B, accessibility, C, interoperability, or D, reliability? The answer is B, accessibility. Accessibility ensures that AI technologies can be used by people with disabilities, promoting inclusiveness and equal opportunity. A company is developing an AI tool for job recruitment. How should they ensure the tool is inclusive? Is it A, focus on speed of processing, B, implement strict security protocols, C, use diverse training data, or D, reduce operational costs? The answer is C, use diverse training data. Using diverse training data helps prevent bias and ensures the AI tool fairly evaluates candidates from different backgrounds. Why might an AI system that performs well in one region not be inclusive in another? Is it A, lack of computational resources, B, high latency issues, C, inadequate security measures, or D, cultural and demographic differences? The answer is D, cultural and demographic differences. Why this question may seem a bit tricky? It assumes performance equates to inclusiveness. Cultural and demographic differences can affect how AI systems are perceived and used.
If you're finding this helpful, please take a minute to like this video and subscribe to our channel for more practice exams, useful tips, and complimentary study sessions with Birdsy.
Scenario questions and ethical trade-offs. Ethical dilemmas: accuracy versus explainability, performance versus fairness. What is a common trade-off when prioritizing model accuracy over explainability in AI systems? Is it A, increased fairness, B, reduced transparency, C, improved user trust, or D, higher computational cost? The answer is B, reduced transparency. Prioritizing accuracy can lead to complex models that are difficult to interpret, reducing transparency and trust. Which ethical dilemma arises when a model's performance is prioritized over fairness? Is it A, increased transparency, B, enhanced accuracy, C, potential bias, or D, decreased complexity? The answer is C. Prioritizing performance can lead to biased outcomes, affecting fairness and potentially discriminating against certain groups. Why might a highly accurate AI model still be considered unethical? Is it A, it may lack fairness, B, it is too complex, C, it uses too much data, or D, it is not user-friendly? The answer is A, it may lack fairness. A model can be unethical if it lacks fairness or transparency, even if it is highly accurate. A company uses an AI model that performs well but is difficult to explain to stakeholders. How should they address the trade-off between performance and explainability? Is it A, ignore explainability concerns, B, focus solely on performance, C, simplify the model, or D, provide clear explanations? The answer is D, provide clear explanations. Balancing performance with explainability can be achieved by using interpretable models or providing clear explanations of complex models. In what situation might a less accurate model be preferable to a more accurate one? Is it A, when speed is essential, B, when fairness is prioritized, C, when data is limited, or D, When cost is a concern, the answer is B. When fairness is prioritized. Why this question may seem a bit tricky, accuracy is often prioritized, but in cases where fairness or transparency is critical, a less accurate but fairer model may be preferable. A financial institution uses an AI model that is highly accurate in predicting loan defaults, but has been found to disproportionately deny loans to minority applicants. What ethical trade-off is being highlighted in this scenario? Is it A, accuracy versus explainability? B, explainability versus fairness? C, performance versus fairness? Or D, accuracy versus performance? The answer is C, performance versus fairness. The scenario highlights the trade-off between performance and fairness. While the model is accurate, it may perpetuate bias, leading to unfair treatment of certain groups.
Thanks for joining us today. If you found this video helpful, subscribe to our channel for more practice exams, tips, and tricks. And don't forget to visit Birdsy.ai for complimentary study sessions with Birdsy, your AI-powered study partner.